Draw the products of the following reactions. Also indicate whether each reaction is an oxidation or a reduction reaction. Here we are being given 6 reactions and we wanted to identify what kind of reaction is this, what is the product that is obtained, and also find out whether it's going to be an oxidation or reduction. Let's take a look into the first compound. The first compound is an alkyne. What kind of reactions do alkynes undergo? Alkynes would undergo electrophilic addition reaction. Anytime you have an alkene or alkynes, it will undergo electrophilic addition reaction. Let's take a look in the reagents. We have sodium in liquid ammonia. This is going to be a reducing agent, right? And it is going to put the 2 hydrogens across the carbon-carbon triple bond in the opposite direction. So basically, it is going to give us a trans alkane. If you're going to use Lindless reagent in the presence of hydrogen, this is going to give us cis alkane. But now, since we are using sodium in liquid ammonia, this is going to put the 2 hydrogens in the opposite direction. Okay, so basically this is going to give us a trans alkane. Let's draw the structure here. So since we are adding hydrogens, this is definitely going to be reduction. So we'll call this as reduction. Let's go on to the next reaction. In the next reaction, we have an amide. Amide reacted with lithium aluminum hydride followed by addition of water. Now, lithium aluminum hydride is a strong reducing agent, so this is again going to be reduction. Okay, and let's identify the product that will be obtained. Here, this carbonyl group right here will be reduced. It will be reduced to a CH2 group. So therefore, you are going to get an amine, secondary amine. This is reduced to a CH2 group. Let's go on to the next reaction. Next reaction, we have an alkene. So alkenes will undergo electrophilic addition reaction, and with hydrogen in the presence of palladium catalyst, this is going to get reduced to an alkane. Again, you are adding the 2 hydrogens across the carbon-carbon double bond. So write down the product, propyl benzene. So this is electrophilic addition also, and since you're adding hydrogens, this is going to be reduction. Let's go on to the next reaction. In the next reaction, we have an aldehyde. Aldehyde, when reduced with hydrogen in the presence of nickel, is going to give us an alcohol, right? So remember, when you have a primary alcohol, when it is oxidized, it's going to give us an aldehyde, and which under further oxidation is going to give us a carboxylic acid, right? And the opposite is going to be true for reduction. So carboxylic acid, when it is going to be reduced, it's going to give us an aldehyde, and then it's going to give us a primary alcohol. The same way, when you have a secondary alcohol, this when oxidized is going to give us a ketone, and the opposite is going to be reduction. Ketones will give us secondary alcohol when reduced. Here we have an aldehyde, which when reduced is going to give us a primary alcohol. Let's draw the structure here. So this is going to give us benzyl alcohol. In the next reaction, we have an ester reacting with lithium aluminum hydride. So this is also going to be reduction. And we said this is also reductions. And when it is reacted with lithium aluminum hydride, this is going to get split as 2 different alcohols. So this part right here is going to be 1 alcohol. So where you will be replacing with CH2OH. And then this side, this methoxy group is going to be reduced as another alcohol. For the last reaction, we have an aldehyde reacting with peroxy acid. What kind of reaction is this? Is there a name for this reaction? This is called as Baeyer-Williger oxidation. And the name itself says that this is going to be an oxidation reaction. So let's put oxidation here. In a Baeyer-Williger oxidation, what's going to happen is the oxygen is going to be inserted either between the carbon-hydrogen bond here or between carbon and phenyl group here. Okay. Now, which of this is going to be formed as a product? For that, we have to look in the mechanism of the reaction, where we'll discuss about the migration ability of the different groups that is attached across the carbon-oxygen bond. So here we have hydrogen and as well as a phenyl group. Let's look into the order of the migration ability of the different substituents. Here is the migration ability of the different groups, and you can see here we are comparing between hydrogen and phenyl group. Obviously, between hydrogen and phenyl, it is the hydrogen which is able to migrate. So you're going to put the oxygen in between the carbon and hydrogen bond. So the product here is going to be a carboxylic acid. As told before, since you're adding carbon-oxygen bond, this is definitely going to be oxidation, and hence the name.